Hello, and welcome to this week's YouTube live session from Impact Subsea. I'm Ben Grant, Managing Director of Impact Subsea, and as always, I'll be answering any questions you may have live here on YouTube. Now, this week, we're going to talk a little bit about the ISM3D AHRS sensor. So this is the sensor itself here. It's the smallest sensor that Impact Subsea manufactures, and it's an attitude and heading reference system. So it provides you with heading, pitch, and roll. So the sensor itself has a flat end here, and it's four M5 tapped holes. So that's for mounting it down. So if you've got an ROV, you can mount it to a big plate there, or if it's going on a subsea structure, that's a great place to mount it and get it really solidly connected to the structure of the vehicle. Alternatively, there is also a recess around the middle of the sensor there, which allows you to put a standard U-clamp around it and lock it in securely. Other than the connectors side for mounting it, you've got the connector for electrical connection, just a standard subcon, which has the same pinouts as all of the Impact Subsea sensors. So the sensor itself, it's available in titanium metal, which is this one here, depth rated down to 6,000 meters. We also do the same sensor in exactly the same size of housing in acetyl plastic. And that sensor is depth rated down to 1,000 meters, and it's a lighter weight version. So it's ideal for small vehicles and anywhere where weight is a consideration. So the sensor itself provides you with heading to magnetic north to plus minus half a degree of the local magnetic heading. In terms of the attitude, it gives you pitch and roll to 0.07 degrees accuracy. So it's highly compact, but also high accuracy attitude sensor. So we get a number of questions on the ISM3D. One of the most common ones is how good is it when it comes to magnetic immunity? So if you're on a vehicle and you're working around, say, steel structures, how well does it hold heading? So I guess to answer that, I have to tell you a little bit about how the sensor works. So the ISM3D has got two modes of operation. The first mode is basically magnetic heading. So it follows it like most MEMS-based magnetic sensors. Inside the sensor, it's got three magnetometers, three gyroscopes, and three accelerometers. The accelerometers and gyroscopes are relatively high grade, so it gets the high grade attitude readings. When you're working on magnetic heading, the magnetometer is flying north on initial power up, and then they'll follow magnetic north, and they'll be slaved to the gyros and accelerometers. So the gyros will help prevent any temporary magnetic interference from affecting heading. So if you have a temporary magnetic interferer come alongside it, the magnetometers will quickly spin off and point towards it, or be moved by it. But the gyros will realize there's not been any physical movement, and will hold that heading. If the magnetic presence sits there for a long time, the heading will slowly creep round and offset to it. So that's the basic mode of operation. However, it's got a more advanced mode of operation, which is probably the number one reason that people purchase ISM3D, which is its inertial mode. So in inertial mode, when you power up the sensor, on initial power up, for the first 10 seconds or so, it uses the magnetometers to locate north. Then after 10 seconds, the heading update gets handed over to the gyroscopes and accelerometers. So after 10 seconds of operation, it will have a heading, and you can bring it alongside a magnetic structure, even a strong magnet you put right next to it, and the heading won't move at all. Even if the magnet is left there for hours and hours, the heading won't adjust at all, because it practically ignores the magnetometers and just changes the heading based on the gyroscopes. So this gives you a really reliable heading, which is ideal for operation around steel structures or any other structure that has a magnetic element to it. In terms of drift, usually you don't want to do that kind of setup with a kind of low-grade MEMS sensor, because what you get is drift over time, and there's nothing to correct the error. With the ISM3D, you can if you sit it on a desk and don't move it for 24 hours, you'll probably get about a 1 to 2 degree drift just from a static installation. Where you get error building up in the heading is from dynamic motion when working in inertial mode. And that's due to integration error of the gyros. So if you're on a large work class vehicle, which many of the ISM3Ds are, you can maintain operations for many hours because the dynamic motion is usually relatively slow. Whereas if you put this onto a small vehicle, such as a small video array or a vehicle that kind of size, you'll find if you move very quickly and rapidly, error will build up in the heading. But at any point, you can move away from the steel structure, click realign to magnetic north, or you can paracycle it and realign to magnetic north and give you a good base to start from again. Another question we often get asked is, can I swap out my existing heading sensor with the ISM3D? And the answer is yes, of course. We've done a few things in the ISM3D to make that a really simple process. So the ISM3D can output impact subsea strings, can output basic strings such as heading, pitch, and roll. It can output more advanced strings that have quaternion points to calculate the heading and orientation of the sensor. But it can also output any industry standard string. So the sensor has an emulation capability. So it can emulate any other heading sensor or pitch and roll sensor out there in the market. And this means you can configure the ISM3D to very quickly just plug into your system without any re-engineering of your ROV or system that you have. In terms of the physical interface, it has RS232 and RS485 serial interfaces in it and can work on any of the standard baud rates as well. So interfacing and integrating the ISM3D is usually a relatively straightforward task. Another question we occasionally get asked is, are there OEM options available of the ISM3D? So the majority of ISM3D units are either in a titanium housing or in a plastic acetal housing. They're highly compact and they work with the majority of applications that we see. We do also offer an OEM version, which is a PCB only solution. So if you don't want the housing, if you don't want the connector, and you want to integrate it directly into, say, a very small AUV, into your own electronics pod, then we offer that option as well. I think that's all the details on the ISM3D sensor. Just checking. I've not had any questions come through this morning. So we'll end the session there. So if you want any more information on the ISM3D, you'll find the latest datasheet, manuals, demonstration videos, and more technical information on our website, which is impactsubsea.co.uk. Or you can drop us an email at support@impactsubsea.co.uk. We'll answer any technical questions that you have. Bye for now.